Hello, everyone, and welcome to today's webinar, Maximizing Quality and Yields Through Plant Centric Automated Controls. My name is Eric Sandy, and I'm the digital editor of Cannabis Business Times. We are pleased to welcome Michael Heaven, Vice President and General Manager of Argus Control Systems. Today, Michael will be discussing how an ideal control system will not only automate growing processes, but will also monitor and react to the needs of the plants and even anticipate specific requirements such as watering or feeding cycles. With a plant-centric system, users have a more comprehensive interaction with the growing environment, which can be used to steer plant outcomes toward key targets for cannabinoid and terpene profiles and THC content. Just a few notes real quick before we get into the event. You'll see on your screen a box where you can type in questions. Please feel free to do so. I'll be gathering those as the webinar goes on, and we'll have time at the end where I will relay them to Michael for a little bit of Q&A. Also note that we will be saving and archiving the audio and video today. So if you need to leave at any time, that's fine. We'll be sending an email to all registrants, making sure that you have a copy of the presentation today. It'll also be on cannabisbusinesstimes.com in the very near future. With all that, I'm very pleased now to welcome Michael Heaven.
Thank you, Eric, and good afternoon, good morning to everybody. I'm pleased to be here to discuss plant-centric automated controls. And what I will cover in this presentation is what do plant-centric controls bring to the grower? Where are they used when it comes to plants? How do you pick the right environmental control solution? What are key considerations you should think about when you're looking at this topic? What are plant-centric and why are plant-centric controls so important? Common mistakes people make, and some examples of control examples where we've done various types of integration, as well as some ways to be able to see what's happening relative to the plants, always in mind. So let's see. Sorry, just get my controls here. Some benefits of plant-centric controls: being able to control the environment at the plant canopy despite disturbances from many sources. And when you're thinking about disturbances, feeding and watering is a big disturbance that goes on regularly at the plant canopy. And if you're not measuring and controlling it with that in mind, then you have a much larger disturbance from every time you accomplish that. Being able to feed and water and keep the plants in an optimal state to grow the plant, maximizing yield without putting the plant either in a very stressful situation or in a situation where the plant is unable to transpire and pass gas and out to the environment. And automating the routine tasks that growers face through the various cycles of the grow, and eliminating the difficulty of doing all of that manually. Other benefits: managing the complex hierarchy of environments. Example is you've got a greenhouse with plants in it, and you have an over temperature situation. There's a hierarchy you can deploy that will be much cheaper than obviously trying to cool that environment with more expensive HVAC solutions. So open roof vents, blow air through the canopy, use the cheaper elements before turning on the more expensive elements. Being able to schedule events over the entire grow cycle, obviously turning lights on and off, being able to feed and water at different cycles and different recipes for different types of plants from grow to grow. And then anticipating and adjusting the environment when you have a disturbance that you are introducing when you feed or water those plants. Those are some of the benefits of plant-centric controls. Where have they been used? Pretty much across any kind of growing environment, whether it's a greenhouse, whether it's a controlled growth chamber, whether it's a drying process, whether it's the preparation of the physical plants, managing the energy balance, boilers and chillers, through to being able to feed and water and control lights. And in today's world, lighting is becoming more and more critical. There's so many more variables than just turning the lights on and off in the traditional greenhouse. Now we're dimming, as well as we are changing frequency and spectrum in the lights. Being able to handle different zones within the production environment and manage and schedule all of that. And probably the most valuable element is just having that visibility into your entire operation at a glance through a mobile device or through a desktop interface. So if you look at making choices relative to the right environmental controls, probably the biggest, it's really, these are very simple things, but it's surprising. You go into operations and you discover that really the rooms weren't designed for plants. They were designed for people, and then plants show up and they don't behave like people. So look for controls that are designed with the plants in mind, that are measuring the things that matter to the plants. At the canopy level, they're measuring what's going on in the plants, being able to look at the inputs and outputs of that chamber and understand how much moisture has come out of the chamber for going through various feeding and watering cycles, and considering all of that in the environment, in the control strategy. If you, for example, are about to hit a fertigation cycle with the plants and you don't anticipate the effect of that cycle and ramp up your dehumidification, the plants will be unnecessarily stressed by wide swings in humidity, which leads to disease and mold and other things that are undesirable. So being able to minimize those disturbances is one of the key benefits of plant-centric controls. Key questions again that you would want to consider is do the controls calculate things that matter to the plant, such as a vapor pressure deficit, essentially the relationship of the plants to the environment they're sitting in terms of humidity and temperature. If you're asking your control supplier, do you calculate VPD, and they stare at you and look confused, then that's not a good sign. Can you maintain the plants at the right temperature and humidity regardless of those disturbances? And do you model those disturbances? And are they all integrated? Many times we see a control environment, and at the time that it's implemented, the CO2 dosing is not actually commissioned for a variety of reasons. And then when it is commissioned, it doesn't tie into the rest of the system. So there's no way to measure that other than the sensors themselves, but I can't manipulate the CO2 content. So it's really critical that you have all manipulated variables at your disposal with the controls and be able to bring that information into the control strategy. And something that we don't see that often, but that can definitely be a benefit to the growers, and it will also allow people to filter out people who know what they're doing versus people who haven't considered the plants in their strategy, is say, can you give me a guarantee of ability to control the environment at the plant canopy? And that will expose people who understand what the plants do to that environment versus the ones that don't. Many of the grow rooms that we now interface with are controlled by building management solutions that have grown up from the traditional environments where people and buildings come together, and the typical systems like lighting, electric controls, HVAC, security, fire control, all come into these building management solutions. And if you have a building management solution, then quite often they're communicating to a plant-centric control solution through communication protocols such as BACnet or Modbus. And they do allow integration from multiple systems. And we'll show you some examples of deep integration between building management solutions and plant-centric control solutions, and how that can be very seamless when it comes to the operators interacting with the system. There are obviously pros and cons. What we see in building management solutions, pros are obviously it's able to manage big environmental spaces with people in them. It's designed typically not to stress the equipment, so there are ramp rates and protections and dead bands and other things brought into the equipment through the supplier that extends the life of the equipment. but sometimes that also means that you can't get to the target that you're trying to get to until it allows the system to recover. There's a large network of support, which is a critical consideration in getting people when something doesn't work. And you can set it up to be quite an effective partnership with Plant Centric controls. But when you get into the scenario of trying to implement all of those controls in a building management solution, quite often it becomes a very special implementation, and it's difficult to find support after it's commissioned. So, I think the notion around being able to look at the plant-centric sides of that, if there have been examples we've seen where that's been well done, but again, it comes down to being able to support that over time and continually optimize that as things change in your operation. Examples of some plant-centric controls that are typically not in building management systems is integration of climate, light, carbon dioxide dosing, integration, nutrient delivery, all within a single modeling program. So it's considering the effects of the different decision-making, the different scheduled stages, feeding and light cycles and dark cycles, and what has to happen when that occurs, all automated in one environment. Management of things like daily light integrals, how much light is getting to the plants at the plant level, and how is that integrated so that you are achieving a certain amount of light every period that you want to achieve that light, and you're augmenting that in the greenhouse environment, for example, with turning on additional lighting when required. I mentioned the vapor pressure deficit. Now we'll get into that a little bit more in the discussion coming forward, but being able to calculate that at the plant canopy and understand exactly what's going on in terms of what the leaves are being exposed to. Having a model of the plant transpiration and evaporation that is going on, and what irrigation and nutrient requirements are required to optimize that model. Scheduling and feeding over an entire growth with different recipes, and then drying algorithms seem to be one of the things that are very interesting in the cannabis space, is being able to dry without creating mold or other issues, by able to control the trajectory, but also be able to draw the moisture out of the buds through an automated burping-like process where you actually change it and run it through different strategies to get the moisture out of all of the materials. So all of those are very plant-specific algorithms that are not typically in a building management solution. So when we come to vapor pressure deficit, if you think about it from the plant's perspective, it's really, if you imagine yourself standing inside the leaf and looking out, you're saying, is the vapor pressure in the leaf compared to the vapor pressure of the air outside? And obviously, if the environment is very dry, then I'm going to have a tendency to suck moisture out of the plant. And if the environment is very wet, humid, I'm going to have difficulty in getting moisture out of the leaf into the environment. So being able to think about that from the perspective of what does the leaf experience in the environment, and how is that creating a challenge when it comes to removing and exchanging the gas at the leaf environment. So if you look at this table, this green area in the middle shows an optimal vapor pressure deficit between 5 and 12 in this example, that plants open their stomata, increase transpiration rate, and release a considerable amount of water or vapor into the environment. That increases photosynthetic activity, and if we're feeding them more nutrients and they're in that stage, they'll improve the growth of the plant during its vegetation and flowering stage. If you're in these extreme areas in this chart, which are shown in the very red area on the right-hand side over here, you're going to have a situation where the plant is going to close its stomata, because too much water vapor will be drawn out, because dry air is literally sucking moisture out of the plant, which stresses the plant. And if the VPD is too low over here in the light pink area, the plant will close its stomata to prevent releasing moisture into the atmosphere, which is already saturated. And that will also reduce transpiration, which has a direct impact on the plant yield. So being able to keep it in the green area or in the area that's close to that, regardless of the disturbances that occur due to feeding and watering, is a critical element of controlling the plant environment. Another area that's very, very common now is around the LED environments, which LED lighting is really bringing us a huge new variable with being able to control not only light intensity, but also the spectrum that you're bringing out. And we've been running some tests here where we change spectrum, ratio of blue and red lights, and you can see the plants stretch, grow really long stems, and you know, you'll get certain things occurring, but that balance is going to be really critical at the stages where the plant is stretching and growing and expanding its leaf area, and then a different ratio of light when you're actually in the flowering stage. So being able to change from a ratio of blue-red and going more red during the flowering phase, changing the amount of intensity as well, gives you a huge new variable that can manipulate cannabinoid, terpene profiles, THC content, and change a situation in terms of being able to achieve some of the yield desires beyond just kilograms or pound yield, but we're talking about things that are that make the grow more appealing to the consumer. So if you wanted to look at implementing plant-centric controls, avoiding some common mistakes that we've seen in the industry, I mentioned already sort of the notion of a plant, a control system designed for people but deployed for plants. And that's probably that's one of the most common decisions that are made and that people then come back and are trying to re-engineer that environment, which can be quite expensive. Designing a heating, cooling, dehumidification system without considering the impact of the plants. If you calculate the number of plants that go into an environment and you start thinking about its load or its impact on the controlled variables, and you have an experienced grower at the table, they're going to tell you exactly what that environment will experience when we water the plants or we feed the plants. Not including all manipulated variables. So many grow operations don't have fans integrated into the strategy, and when the plants are transpiring, they need a certain airflow between 100 and 150 feet per minute through the canopy to actually have the stomata exchange gas with the environment. So if you don't have that airflow, or you don't have the ability to manipulate the fans, then you can't maintain that airflow through the canopy, and as a result, you're not operating in an optimal way from the perspective of the plants. Often I mentioned CO2 not being integrated in terms of how we dose, and dosing separately. It becomes a manual function, and obviously feeding and watering not being integrated in with the rest of the controls. Lastly, it's always around energy and balancing out everything. So if you don't think about the hierarchy of costs in your solution, you might have to turn on HVAC when you don't really want to turn on HVAC. Sometimes we also see inadequate ranges of inputs to control the plants, and being able to hit these limits during a control or feeding cycle really causes us a number of issues with disturbance that cycle on for quite some time. The other thing we see is that a lot of times we'll ask for a given set point, and the HVAC system will be ramping, but it won't be ramping fast enough, and we can't get in there to change that variable because that's sort of down in the guts of the system. We've gone through an exercise where we actually eliminated those ramping restrictions and dead bands in the HVAC solution, and we were able to double the temperature accuracy by that process. So if you are getting into a situation where you're not getting what you want, it's quite often buried inside that something isn't tracking where it needs to. And then finally, sensors and being able to have enough resolution, defining your zones as plants grow, moving those sensors or having sensors that can pick up the plants as they become taller, and having a discipline around making sure those sensors are where they need to be, so that you are looking at zone disturbances as opposed to changing the entire environment and affecting the ones that don't need to be affected. So what we're seeing in today's world around innovations from plant-centric environments is there more plant-specific algorithms are coming out that are modeling all of these different factors and looking at it as a multivariable control optimization solution. We're seeing more sensors that are coming, more of a density in the canopy environment. So we're measuring the environment with much more resolution. So we can see a dead spot over around a door. We can see cold spots caused by fans that aren't optimal, and that gives a great solution for growers to be able to say, your problem in this grow area is this particular issue. Machine learning is coming with yield optimization, and you can put in cost functions and balance all the different factors that go into producing that yield, and then trade off, okay, I can only go up to this level, where beyond that it's going to be cost prohibitive. Being able to have devices now and visibility into your process from wherever you are, and be able to interact with that process and see the alarms. People go through team viewers and various very difficult, cumbersome solutions, and more it's coming down to your mobile phone or a tablet that you're interacting with your environment. And then finally, integration of plant-centric data with images and plant health, so you can actually see the plants performing over and how they're being affected by the environment. This is just an example of some trends on an Argus system that have integration with some of the images of those plants, and you see VPD, humidity, and CO2 here tracking through cycles, and what the plants are looking like in their environment can be called up on the trends as you go forward. This is another example of plant-centric dashboards that have been implemented, where at a glance you can see all your alarm statuses, what your environment is doing, what your pH and EC levels are in your operation, and you can drill into any zone and see what's happening over time. And the idea is to have that at your fingertips if you're the growers, and then you can design it for having a head grower has every access, but the other growers are focused in on the operations that they're responsible for. This is an example of a research greenhouse under control, where you see temperatures and humidities and set points of all these different variables being controlled at a glance, and you can set up your schedules accordingly. This is an example of dry room controls, where you're actually controlling through a whole drying sequence, the drying, what's going in the room, what's coming out of the room, and you're optimizing that for hitting a given drying trajectory as short a period of time as possible. This is just an example here of a good integration solution between a environmental control solution designed for plants and a building management solution designed for people. And so in this particular example, growers enter all the set points, recipes, and schedules into the Argus system. Argus communicates seamlessly with the building management solution HVAC, and set points and actuals are visible on both systems. So you can see the Argus set point, you can see what's happened with the controls, and I'll show you some examples of that. Sensor readings are fully integrated and visible on both systems, and the actual variables are all being passed essentially across the network without anybody having to program it differently. And users can see at a glance what's happening and click between the systems. At the high level, there's essentially an example of the rooms of what's going on. You can see visibly the rooms that are in day cycles or in night cycles. You can see a room that's in correct temperature control with the set point, if green being just right, red being too hot, and blue being too cold. so you can visibly see that graphically and then drill into the room. You also see Argus set points here coming in on the temperature and humidity set points for this particular zone. You can see the equipment that is then accomplishing that, and the control status, and everything nice and graphical, so people can see exactly what's happening within the equipment and that it's tracking correctly. Here is an example of chilled water controls, again with Argus weather station measurements coming in as one of the variables associated with that controls. And a hot water system here, again, taking into consideration the environmentals, being able to see trends. This is just a simple example of, the lights are on in the room, and we see the lights, bright lights on the room, and then the lights are off in the room. So you can very easily, just at a glance, and it's possible even here to say, okay, the lights are in blue or blue cycle, so you would see the lights looking blue, and that could tell you that you've now implemented a spectral adjustment to the lights. I think what I'm really trying to show here is that it is absolutely possible to have a good integration between building management solutions and environmental controls if you are working together from the beginning with the goal of implementing everything that the plants need. And the plants' considerations has been part of the discussion points all the way through the design of the equipment, the rooms, and the integration. So that's the presentation in terms of the topic I wanted to cover. So if we can hear some questions and answers now.
Yeah, absolutely. Thank you, Michael. That was fantastic. Definitely appreciate the insights there. I wanted to start with just sort of a broad question about vapor pressure deficit, and just if you could elaborate a bit on how that's measured and the importance of where in the room the system is taking those measurements, and sort of how frequently those measurements are being updated in the system.
So if you design your system with with zones, which is typically done in growing environments, there'll be a sensor hanging in the plant canopy or mounted in the plant canopy that will be associated with that zone. And that sensor will measure temperature, relative humidity, CO2 content, pretty much everything. In some cases, it'll measure soil moisture, but it gets as many measurements in that zone as possible. And then from those measurements, I can calculate the vapor pressure deficit, which is just essentially an equation, and I can determine, compared to an optimal level of that deficit, or the difference between the leaf humidity and temperature and the environment's temperature. I can see that relative to what's going on at that zone, and we're calculating that every time we receive a reading from that. We are calculating the VPD, and it's on that trend line that I showed, so that you actually see what's going on in a VPD calculation in that zone. And those readings are typically taken every second.
Excellent. Yeah, and speaking of that chart, we had a very brief question here. Had you guys drawn that chart up for cannabis, or would that relate to other plant species as well?
Particular charts for cannabis, but it relates to other plant species as well. It's just that there'll likely be different numbers in the table. But there's always an area that's sort of that sweet spot where it's not, where the balance of things are such that the plant is thriving because it's able to open its stomata. That's the first question. And then it's able to exchange in an optimal way, not sucking moisture out at an incredibly rapid rate, drying the plant out, but doing that in an optimal way. And that's why it's not just an absolute number, it's a band.
Sure, yeah, we have a question here about how plants transpire that moisture over, say, a 24-hour time period. That rate, that measurement, would be the product of those multiple factors then, right?
That is correct. And it transpires differently when under light conditions, then when it's under dark conditions, and you've got to take all of those into consideration as the plant is transpiring. People have tried to measure things like the moisture content in rock wool, for example, and being able to, or weigh a skid of plants to determine how much moisture is in the pot. That people also measure the amount of moisture that comes out by measuring condensate coming out of the room and getting an aggregate measure of how much condensate is coming out versus how much water and how much came in with the environment, with the air as it was conditioned. So what I'm trying to say is that there's ways to model all of those different interactions and take them into consideration in your controls.
Yeah, and in terms of actually hanging or installing adjustable sensors, within the canopy, are there any best practices there, or any things that you would recommend growers avoid doing?
We see everything from sensors that are hanging, right in the middle of a breezeway, coming from a fan. We see sensors that are not even close to the plant canopy, so they're measuring an environment that's very dry at the upper part of the room, but what's going on at the canopy is quite different. Best practices would be to have those sensors track the canopy and be buried in the depth, because what you really care about is what's going on the underside of the leaves. So you don't want to be looking down at the canopy. You want to be buried in the canopy, and we have enough sensor density that you can identify what we often see, which are dead spots. There's no airflow in this area. This area is too hot. This area has a humidity spike. Every time we open this door, we see an impact, and that's why these plants are looking yellow.
Sure, yeah, and I know we have a lot of growers who are always making adjustments or making changes of some sort to their equipment. So it's sort of a two-part question here, I guess. Let's say someone's transitioning to LED lights. How would that affect the vapor pressure deficit calculations? And also, more broadly speaking, how should growers factor those sorts of changes and transitions into a system like yours?
Well, I think that's a good question and a tough one, because obviously, if you change from high pressure sodium lights to an LED light, you're going to change the heat load in the room, and that's going to immediately impact your temperature controls. The LEDs give you a new elements, often dimming, but also you have the ability for spectrum. So you absolutely need to bring that information into your control decision making, so that you can consider that impact. You may get to a point where those kinds of changes will affect and move your environmental controls out of a sweet spot, and you'll have to then make some adjustments. Maybe you have to change your airflow further than you've had to in the past. But airflow in particularly in the cannabis industry seems to be one of the areas that we see regularly people struggle with. We see fans bolted to the ceiling. We see fans pushing air through the canopies. Greenhouses have this beautiful ability that they just naturally pass air through the main area of the greenhouse. They have vents in the ceiling, so you have nice cheap ways to get temperature out or to balance humidity. Whereas we see in a lot of closed growing rooms that consideration isn't there, and airflow isn't easily manipulated. And I mentioned the airflow requirement for transpiration. And if you walk into a room and you can't feel any air moving in the canopy, you've got an issue.
Yeah, we have a question here regarding scheduling or the changes in a feed recipe over the course of a grow cycle. So is the system able to schedule out the different changes that a recipe might have over the course of a grow cycle?
Absolutely, and we can support up to 64 different recipes, basically anything you need. And if you had to go more than that, we can, but you can absolutely change your recipes, and always do through the growing environments. We do encourage people to look carefully at recipes, and in their deployments, we see recipes in flower rooms that are relatively consistent, and the more you can have consistency, then you can then do more optimization in terms of yield improvement. But once you figure out the right formula that gives you the right yield, then we automate that whole process of deploying that wherever you want that deployed.
Okay, we talked a lot about integrating alongside or overlaying on an existing building management system. But could you elaborate on the idea of integrating a plant-centric system into just day-to-day human systems, and what sort of what teams can do to adequately integrate a plant-centric system into the work they're already doing day to day, or things they should not be doing? I can clarify that if need be, but if you follow me, sort of integrating this into just team tasks day to day.
I think if there's a grower at the table when you've designed your facility, the grower is going to be already saying, "This is what I need every day. This is what I need in order to be able to interact with the system," and they're quite often very familiar with doing this in a variety of growing environments. So they've worked with plant-centric controls, is what I'm trying to say, and they say, I need the ability to manipulate my recipes. I need to be able to feed and water, and I need to have the system maintain the environment despite the fact that I am doing those things. And in terms of being able to integrate it, I would just say that the approach has to be to bring the plant-centric view, the grower, and the equipment suppliers together as early in the project as possible. Or if you have already an existing installation, get those teams together to talk about what the issues are in terms of getting the right integration out of the gate. And if it's already implemented, then what can we do to control the manipulated variables? And we often will go in and do an audit in a location and say, the problem you have in this room is these things are not tied into the plant-centric controls, therefore we can't control them. And at that point, you can come up with a strategy, as I showed with those examples, where you provide seamless integration. And from a grower's perspective, I want to be able to see at a glance what's going on with those environmentals. And if something is in an alarm state, I want to see that instantly. And the ability at that high level to see, I've got a blue room, what's going on here, that really is empowering for the growers to focus in on the areas that are not under adequate control, as opposed to having to go and walk through and look at two different disparate systems. Did that answer the question, or do you want me to go a little further?
I believe so, yeah. If the person who asked that question, if you want to chime in on the question page here, but I would think that that's at the very least a good starting point. We'll see if we get a follow-up question on that. We have a couple of irrigation questions. One being, for this sort of system, would you need individual soil moisture sensors for every plant to ensure accurate data in terms of irrigation needs?
We see soil moisture measurements as being very difficult to calibrate and to get, especially if you're feeding the plants, which we always are, a mixture that has different conductivity, then it affects the baseline of those measurements. What we've seen is the most accurate way to know what's going on is unfortunately to weigh the plant. So what people do is weigh a certain number of plants on a bench, put a load cell under that, and get an indication of how much water remains in the pot as it's being drawn into the plant. People have tried to measure leaf moisture content for a variety of ways with probes and guns and other things, but the big challenge is figuring out a measurement that isn't affected by conductivity or other variables. And if you're in soil, obviously that's a completely different game than say rock wool or other growing media. So I guess what I'm trying to say is I love to see sensors that are measuring plant properties. We see weight being used as a marker for how much moisture has been drawn into the plant. Soil, amount of moisture in the pot is also used, but it ends up being a very cost prohibitive solution to measure every single pot and know what's going on in it.
Sure. Yeah, we have two questions here, sort of about automation. In terms of sensors that are measuring whether that's EC or pH inside the growing medium, could you describe the automatic adjustments that the system can make for things like water volume and EC and pH to meet the required values? And the other question is similar. As those recipes that we mentioned earlier, as those change, could you describe the automation capabilities of the system to automatically respond to recipe changes? So, two automation questions, one about growing medium sensors, one about recipe changes and how the system responds.
So in our experience, it's not measuring in the growing media. It's actually measuring what is circulating to provide the water and food to the plants. So we're controlling in our fertigation solution the pH and EC that we're feeding into the plants, and then we're measuring what's coming back. And so from that, we're able to maintain it within a desired pH EC level that is associated with that recipe. And you should look for an automated feeding and watering solution that is self-contained. In many cases, inline mixing is used to basically provide a consistent pH and EC reading out to the plants, and then we're monitoring what's coming back to us after it's passed through the media. So it isn't measured in the actual media itself or in the plant growing media. It's measured by the system inputs and outputs. And it is affected by whatever recipe you're running. So different recipes can have different EC/pH requirements.
Sure, that makes sense. And speaking of inputs and outputs, we had a couple questions based on that more technological side of the system. Could you describe, once this data has been gathered, what form it's taking and how shareable it might be, within departments at a company, or how it's read, I suppose, by different people?
So all the data lives in the control environment. At least if I can speak to Argus's system, and you can read that data through an API into an Excel sheet or into any kind of offline tool that you want to use to analyze the data. Obviously, we're providing trends, alarming. If something goes outside of a ramp rate that we find acceptable or exceeds defined limits, you're going to automatically get an alarm as a grower on your mobile device. You're going to be able to see and understand what's going on because we're monitoring all of that information. If you want the information out, there's a variety of ways to do so. We have automated report generators that will report on all aspects of the grow through its sequence. And those can be used for compliance reporting. They can be used for your regular production meetings, for yield analysis, and so on. And some of our research clients are using that for fairly advanced analysis of one grow versus another, and hold all variables constant except for this variable. Now we're going to manipulate spectrum at this stage of the growth and look at the difference, and then feed all that data into a machine learning algorithm to determine what did that spectrum change do to the final yield you were able to achieve. So the data is absolutely accessible and available, and that obviously is another challenge when you're talking about integration, because you don't want some data living in your building management solution, the other data living in the plant-centric solution, neither one talking. I'd say you really want is complete flexibility in terms of bringing data out from one system to the other.
Sure. We had a lighting question relating to, I know you just briefly mentioned in passing there, the manipulation of light spectra. Could you elaborate a bit more on how that works in the system? And one of the questions here also related to supplemental lighting beyond far red spectra, and whether that's part of the system as well.
So if we have any variable that we can manipulate, it can be part of the system is the short answer. It's been a relatively new entrant into the cannabis space to have LEDs even accepted by a lot of growers who traditionally have grown up with other lighting sources and have been very suspicious about LEDs. But what we are seeing is a broader acceptance of that lighting solution. Obviously, it has lots of advantages in terms of life cycle and cost associated with operating it. But the spectrum is one that I think people are studying now to understand the different ratios of light. And the players that are really pushing the envelope on that are looking at a controlled growth environment and putting a plant into that controlled growth environment and figuring out the right spectrum that causes the output to be what you want. So in the formation of buds, can you manipulate that in the final stages of the growth such that you form larger buds or you form different terpene profiles? You come up with a small chamber to do that, and then if we're controlling that chamber, we can just essentially take that same control algorithm that we develop in the chamber and then deploy it in the grow room or in the greenhouse. So that's one way you can really push the envelope in terms of understanding those spectrums. I've looked at a lot of papers with different publications. I really like some of the work Phillips is doing on essentially looking at spectrum and the impact, because sometimes you manipulate spectrum early in the plant cycle, you'll actually have the opposite outcome at the end of the cycle. You won't increase yield, you'll have a negative impact. So being able to understand where in the growth cycle you get the right effect from those spectrum changes is a critical question. And I just say, do your homework and then make sure your control system can take that and manipulate those variables. And if you're working with one of the major LED suppliers, you can be pretty confident that we're probably talking to them too, and we can interface to it, or other plant-centric suppliers can too.
Yeah, and in terms of that that manipulation, maybe even in an R&D sense, or in using certain rooms to conduct experiments on different variables, in this system, are you able to set goals or desired outcomes that you're trying to work toward? That the system, if you're not getting close to that goal, it'll alert you in some way. Are you able to sort of set the point B that you're trying to reach as you work through point A, if that makes sense?
Yes, and I'll give you some examples. In propagation, where your goal is to grow plants to a certain point and hit a day where those plants are now ready for shipment, that is a set of goals that you can say, I want those plants to be ready on day 40, and it'll actually back up what you need to do in terms of the recipes and the controls from day 1 to day 40 to hit that date of when you want those plants available. And why is it a big deal? Because so much labor and transport costs and everything else comes down to hitting that date. If you can guarantee those plants are ready on that date, it's a big deal. You can also enter recipes and yield targets and have the system say that the best way to do this, that would be the lowest energy cost or the lowest input cost within the bands that you've defined, would be to set it this way and run this recipe on it to achieve that outcome. But the question's a really good one, and I see more of that happening with some of the higher end producers that are really trying to say, okay, I'm focusing in on recipe optimization for desired outcomes, because you kind of have to go through that learning process to understand the variables before you can then say, I want this outcome and here's the best set of equations for that. people are definitely doing that, and there's going to be more of that as machine learning becomes more and more prevalent, because that can kind of sift through that mountains and mountains of data and understand relationships that maybe humans can't.
Yeah, and in terms of that,
humans can, but they can't. They don't.
Sure, absolutely. And in terms of that machine communication, I suppose, we've talked about engaging with existing BMS systems. Does this plant-centric system, is it discoverable through BACnet protocol, building in automation and control networks?
So that we can communicate both ways, and yes, it's discoverable through BACnet, and Modbus and other protocols are supported for being able to have data go both ways. And so I suppose if a particular building management solution wanted to become very plant-centric, and then they could communicate with us, but then you kind of say, so our niche is definitely plant-centric controls, and most BMS manufacturers or suppliers are not. But that doesn't necessarily mean that they can't be. And there's the example I showed you there is very deep integration and communication between the systems. Any variable can go either way. Did I answer your question?
Yeah, I believe so. And getting back to human communications, I know we've touched on this a little bit, but in terms of the full grow staff at a company, are you able to integrate different grow staff job duties and day-to-day job routines into the system so that team members of different levels can tap into it and use it for their own needs?
Yes, typically there are different users associated with a system, and those users have different privileges associated with what they can and can't do. A lot of head growers want recipes locked down, so we're not going to change recipes, but you can deploy recipes for your grow. But if you're going to change the recipe and affect our multiple grow environments, then that's something we reserve and have privileges associated with. Can't change programming, is often locked down as well. But no question, we can have hierarchies from very inexperienced people coming in, monitoring what their performance levels are, and being able to see how they perform over time, and have that ID associated with that grow. And then take that all the way up to the head grower that has pretty much all privileges necessary in the system. Alarming can be pushed to users as well, depending on their profile. So the head grower might want all alarms related to a yield issue or a out of control situation, but doesn't want to see the details below that, and that can be configured as well.
Terrific. Michael, I want to thank you for the time here as we wrap. This was very helpful, very insightful, and I think all the questions were addressed pretty clearly. I do want to thank everyone for attending today's webinar. Just as a reminder, we'll be distributing the audio and video, the whole presentation, via email to all registrants in a couple days here, and it'll be posted on cannabisbusinesstimes.com. And once again, Michael, thank you. Thank you to the whole Argus Control team. This was fantastic. Really appreciate your time today.
Thank you very much. And everyone who participated on behalf of Argus and everyone, thank you for that opportunity.
You got it. Thanks, everyone. Have an excellent day.